Okay, so here we go with part two, energy management overview, and we're going to do some calculations here, some math. So the first one we're going to do is okay. So the first one would be a water analysis. We're looking at our current toilet has 12 liters per flush. We're going to upgrade to a 6 liter per flush. Water costs $0.008 dollars per liter, approximately 5 flushes per day. New toilet, pretty cheap at $200 with the install, maybe a bit more than that, but it'll work for today. And what is a simple payback? Going to get rid of that, and I'm going to start here. So our current toilet is 12 liters per flush. We're going to upgrade to a 6. So we're just going to go ahead and subtract that so we get the difference. 6 liters, and this should be per flush. And we'll just call it F for short going forward. So that's the first thing we would need to do, just the difference between the two. And then we are going to kind of factor in the duty cycle. So times 5 flushes per day times 365 days per year. Okay, and so that will tell us about how much water we're going to save. And some quick math on that would give us 6 times 5 times 365, 10,950 liters per year. And now we just multiply that by the 0.008 dollars per liter will give us the cost. So times 0.008. $87.60. Okay, so now the simple payback, SP, and I don't even know the formula. I just always look at these and say, is it going to save me more money than it costs? Well, it costs $200. It's going to save me $87. So therefore, I know the payback will be longer than a year. So if the payback's longer than a year, I put the bigger number on top. So it's the cost, the 200. So 200 divided by my 87.60. And I didn't carry through the year and cross out my units, but I could have. So flushes and flushes is going to cross out with this one. Days cancel out here. And this is $87 a year. And so this is 87 per year here. And when I divide by that, by division, I bring that up to the top, and it's 200 divided by 87.6 equals approximately 2.3 years. Okay, moving on to the next question. Very similar in the level of difficulty here. Let's get this to advance. Come on, computer. Okay, here we go. Now we're looking at a lighting upgrade. And we're going from 150 watt halogen to a 35 watt, 12 hours per day, 15 cents a kilowatt hour. The LED costs 30. What is the simple payback? So again, we're going to start with 150 watts minus 35 watts. And the first thing I'm going to do is convert that to kilowatts, because that's what I like to work with. So 1 kW over 1,000 watts. And let's just figure out work that in. So that would be 0.115 kW. Now we're looking at 12 hours per day all year. So that will give us our kilowatt hours. So 0.115 kW times 12 hours per day times 365 days per year. And I can take it to the next level and even multiply that by the price. So times 0.15 per kWh. And again, so I want to think about crossing out my units. So I've got my kilowatts here and my hours here. So those are going to multiply together and cross out with this one here. So I can go ahead and cross those out. My days are gone, and I'm going to be left with dollars per year. So that would be equivalent to, clear, 0.115 times 12 times 365 times 0.15, about $75 in savings. 75.55. This is dollars per year. And again, so my simple payback, without even knowing the formula, I'm looking at it. The LED cost me 30. I got 75.55 savings per year. So I know it's going to be less than a year. So I need that bigger number, the 75 on the bottom. So I've got my, and maybe we'll actually write the formula this time. So it's my cost over my savings, which is equal to 30 divided by the 75.55, or equal to 30 divided by 75.55, 0.4 years. This should have been years here. And my dollars cancel out, so 0.4 years. Which is the main reason residentially outdoor lighting that has a high duty cycle is almost a no-brainer when upgrading to LEDs. Okay, so a couple key numbers here that we're going to take with us to the next slide, which is the $75.55 per year savings and the 0.115 kilowatt hours. Let's see if I can make this work. So that was 75.55 dollars per year savings and 0.115 kilowatts of difference, I guess we call it. And I guess the last one would be we paid $30 for the bulb. $30 per bulb. A couple key numbers that we're going to need for this one. So we've taken those lighting and we've moved it inside. And we say the heating system operates 8 months per year. And there's two options here. The current heating system is oil-fired, 80% annual fuel utilization efficiency at $1.05 a liter. Let's go ahead and do that one first. And my question is, what is the new simple payback when we move these lights inside? Okay, so we're going to start with the 0.115 kilowatts. So that's like a little heater, right? Lights give off 100% heat unless some of that heat is directed outside. We're going to say it's all maintained within the building envelope. So we've lost 0.115 kilowatts of heat by changing those bulbs. So we're going to start with that. The next thing we're going to do is say, well, how often is that? So it's that 12 hours a day again, 12 hours per day. And we've got, okay, this is the tricky part. We've got 8 months per year. So what's the best way to do that? Well, how many days is there in the month? There's about 30, 31. There's no real definite number. But we can take a fraction of the year. What I like to do is I say 8 months over 12 months and times my 365 days per year. Okay, if I put that all in brackets, that's like saying 8 months of the year we're going to have to do some supplemental heating. So that will give me my kilowatt hours that I'm going to need to make up with oil. And I'll show you that. So my days cancel out, and my months, of course, cancel out, and I'm left with kilowatt hours per year. So we'll go ahead and do the math on that. So it's 0.115 times 12 times 8 divided by 12 times 365 is 335.8. 335.8 kilowatt hours per year. Okay, that's the amount of energy that I'm going to have to supplement these LED lights. Okay, and so it's that number, 335.8 kilowatt hours per year. And well, I need to now convert that to oil. And I know that with oil, I'm 80% annual fuel utilization efficiency, so some of my energy is going to go with the chimney. So I need to make this number bigger. So I need to divide this by the efficiency, which is 0.80. So divide that by 0.8. So it's about 419.75 kilowatt hours per year of oil that I'm actually going to use, because I'm throwing, about 60 kilowatt hours per year out the chimney. So now I just need to convert this to liters of oil and multiply that by my price point. So now it's times by 1 liter oil divided by 10.7 per kWh, and W doesn't look good, kWh, and then times my price, which is 1.05 per liter. And I'm going to go ahead and cross out some units here. So kilowatt hours and the liters of oil. So I'm going to be left with dollars per year. So times that by now, or divide, by 10.7 and multiplied by 1.05 will give me 41.19. Dollars per year. Okay, so that's my increased oil costs. And now when I look at my year savings, the 75 up here, that's how much I've saved in electricity. But now all of a sudden I'm spending this much more in oil. So now I need to do my new savings, or my net savings, which would be equal to the electrical savings minus my oil, and this is all per year, and I get 75.55 divided by 41.19. I did a calculator there. $34.36 per year. Okay, so now my simple payback is still good. I'm looking at those numbers and saying, well, $34 is just more than the bulb cost. Again, so my simple payback should be just less than a year. So my simple payback, again, is equal to this cost over the savings, which is equal to 30 divided by 34.36 per year. So that would be equal to 0.87 years. Okay, so that's the oil conversion, right? We went from a 0.4 year of a payback to 0.87 when we factor in the heating costs. So that's for an oil-fired system, and it's going to look fairly similar. I'm going to go ahead and erase stuff here that's no longer pertinent. We're really going to start here. I'm going to start erasing here, and you'll see we're going to use these numbers again. It's just because we're going with the heat pump now, our numbers are going to look a lot better. Oh, shouldn't have deleted that. Okay, so now we've got an an air source heat pump with an 11 HSPF. So HSPF, if we divide that by that special number, and I want to get this right, so I'm going to go ahead and search online just to make sure. .412. 3.412. Okay. So if we take our HSPF and divide that by 3.412, that will tell us the COP. It'll give us our COP. And COP is much nicer to work with. So 11 divided by 3.412 is 3.2. Right? Or we could say that's like a 320% efficient. So if it's 320% efficient, we could take that 335.8 and divide that by our COP of our system, or 3.2, which is then going to give us here. About 105 kilowatt hours, right? We needed 335. Our system's 320% efficient, so we only need 105 kilowatt hours from the heat pump. And we can go ahead. We don't need to do as much math here because we're going straight electricity. So we're going to multiply that by our price of electricity, 0.15 per kWh, and cross out some units, times 0.15, so 15.74 per year. So again, our net cost now, our net savings equals the $75.55 minus our increased heating costs, which are 15.74, and this is all per year. So we got 75.55 minus 15.74 is $59.81 per year. And so that's savings, $59 a year. I know the simple payback then, a bulb is $30. It's going to be about a half-year payback. So SP equals cost savings, which is the $30 over 59.81 per year, is equal to 30. Yeah, 0.5 years. Okay, so that, oil was the worst, but worse than this, but outside lights are even better because we don't have to factor in those heating costs. Again, if we were down in the Bahamas, this would look even better because all of this net savings, instead of doing the minus off of here, we would be doing a plus here because we would be doing more air conditioning, or we'd be doing less air conditioning actually. We've taken a heater out of the space. Okay, so this is go way back to the fall when we did a whole bunch of this stuff, but I just want to make sure this still remains clear. So our current system is an oil-fired, 80% efficient. system. We're going to upgrade to an air source heat pump, again with an HSPF of 11. And I'm going to go ahead right away and divide that by 3.412, and that will tell me the COP, which I think this is the same number. Divide by 3. Will give me a COP of 3.2, or 320% efficient. So we're going to start at the 5,000 liters. So 5,000 liters of oil. Okay. Some of that is being thrown out the chimney, right? It's 80% efficient. So we really need to say, does our house need more or less than 5,000 liters? Well, it's going to need less, because some of that, we're not going to be throwing any energy out the chimney anymore. So we now multiply that by our efficiency, and that would tell us how much energy the house actually needs. And the next step again would be to convert that to kilowatt hours so we can talk the same language. So 10.7 kilowatt hours over 1 liter oil will give me the new, how many kilowatt hours the house needs to heat it. So 5,000 times 0.8 times 10.7 is 42,800 kilowatt hours. And we can go ahead and cross out some units here. So liters of oil gets crossed out, and we're left with kilowatt hours. Okay, the efficiency of the system is 3.2. The COP is 3.2, so we can right away divide that by 3.2, and that would tell us 3.2. We're only going to pay for 13,375 kilowatt hours. And we can multiply that by the price. And we're just over $2,000. Okay? And if we look at it and we said 5,000 liters at $1.05 a liter, well let's do that. So 5,000 liters multiplied by 1.05 per liter now that was $5,250. And our new cost is 2006 minus 2006 minus 2006 is $3,244 in savings. Okay, and we remember back the simple payback formula. Simple payback equals cost over savings. And of course, this is per year. And I could carry this all the way through. It's per year here, and up here it was also per year. So again, my simple payback equals my cost over my savings, which would be equal to 10,000 over my savings, my 3,244 per year. Or about a 3.1 year payback, 3.1 years. Okay. And that concludes part 2, the math part. And we have to go way back to the fall, but this is all good stuff. And looking at air source heat pumps, if you do divide it by the COP, or the 3.412, turn it into a COP, it's going to make the math a lot easier for you.